All right. Unit 5, Lesson 1, Sketching and Analyzing Function Graphs. So we read the story about the hare and the tortoise. The hare was making fun of the tortoise one day for being so slow. Do you ever get anywhere? He asked with a mocking laugh. Yes, replied the tortoise, and I get there sooner than you think. I'll run you a race and prove it. The hare was much amused at the idea of running a race with the tortoise, but for the fun of the thing he agreed. So the fox, who had consented to act as judge, marked the distance and started the runners off. The hare was soon far out of sight, and to make a tortoise feel very deeply how ridiculous it was for him to try a race with a hare, he lay down beside the course to take a nap until the tortoise should catch up. Okay, so we are going to make some tables and graphs with that information. So the tortoise, let's say, was moving at a constant rate of 5 miles per hour. So when we say constant rate, we mean steady, same speed of 5 miles per hour. So at 0 hours, he moved 0 miles. He didn't move anywhere yet. And then after 1 hour, he moved 5 miles. Then he moved another 5, so then that would be 10 after 2. And so on. So we add 5 miles every hour. At 6 hours, that means he went 30 miles, then 35, then 40, and then 45. Okay, he traveled 5 miles every hour. So his total distance went up by 5 each time, every hour. Every hour. Okay, the hare travels 10 miles per hour for the first 2 hours. Then he decides to take a 5-hour nap. So 10 miles per hour for the first 2 hours, then a 5-hour nap, and then he travels 10 miles per hour after that. So he also starts at 0 miles. At 0 hours, he went 0 miles. Then after 1 hour, he went 10 miles because his speed is 10 miles per hour. He's still going at 10 miles per hour after the second hour, so then he's at 20 miles. But then after the first 2 hours, he decided to take a nap. So when you're napping, you're not moving any more miles. So he was stuck at 20 miles for 5 hours. So let's see. This would be 1 hour of his nap, hour 2 of his nap, hour 3 of his nap, hour 4 of his nap, and hour 5 of his nap. And then 1, 2, 3, 4, 5. His 5-hour nap. And then after his 5-hour nap, he travels at the same rate as before, 10 miles per hour. So then he goes up to 30, and then he goes up to 40. Okay, so let's graph this. So let me graph the tortoise. The tortoise starts at 0, 0. Then at 1 hour, he goes 5 miles. At 2 hours, 10 miles. At 3 hours, he went 15 miles. After 4 hours, 20. And you'll notice our slope is just up 1, right 1, really up 5, right 1. But yeah. And again, this is our tortoise. Slow and steady. Okay, now in pink, I shall graph the hare. He also started at 0, 0. But then after 1 hour, he was up at 10 miles. And after 2 hours, he went 20 miles. So notice his line is a steeper slope. He's already being faster than the tortoise right at the beginning, more miles. Then he takes his nap. So he's stuck at 3:20, 4:20, 5:20, 6:20, and 7:20. Then at 8 hours, he goes up to 30. And after 9 hours, he's at 40. This is an interesting graph. Okay, and that would continue as well. So if the race is 40 miles long, who will win? So let's see. 40 miles. At 40 miles on our graph, the tortoise completed 40 miles in 8 hours. The hare completed 40 miles in 9 hours. So the tortoise was faster. And if you know the fable, well, we'll read the rest of it. The tortoise, meanwhile, kept going slowly but steadily, and after time he passed the place where the hare was sleeping. But the hare slept on very peacefully, and when at last he did wake up, the tortoise was near the goal. The hare now ran his swiftest, but he could not overtake the tortoise in time. The race is not always to the swift, or in other words, slow and steady wins the race. Okay, so here's our graph again. Now we're going to talk about if it's linear or nonlinear. So in order for a graph to be linear, so we'll just write some notes off to the side, linear versus nonlinear. Linear means a straight line. Nonlinear means not straight the whole time or curved. If it's linear, it has a constant slope or constant rate of change. So that means the slope is the same throughout the entire graph. If it's nonlinear, the rate of change varies. Okay, so let's use those notes to help us. Is the tortoise's graph linear or nonlinear? So I'll put that in yellow here. Here's the tortoise. A nice straight line. Think it's linear if you can line up your ruler with it, and you'll be able to draw it with a ruler. So this is linear. The hare, would you be able to draw that entire thing with just one stroke of a ruler? No. So overall, that graph is nonlinear. It has 3 linear components, but the whole graph is not one big straight line that you could draw with a ruler. Is the part of the function for the hare from 2 hours to 7 hours linear or nonlinear? So from 2 hours to 7 hours, that would be right here, 2 hours to 7 hours. So that is a straight line, so that is linear. Is the function representing the tortoise strictly increasing or strictly decreasing? So the tortoise, as you go from left to right, is going upward, positive slope, so it's increasing. Describe what is happening along the entire function for the hare. Okay, so for the hare, from 0 hours to 2 hours, it is increasing. From 2 hours to 7 hours, it's not increasing or decreasing. It's at just a constant at 20 miles. And from, let's see, 7 on, the function is increasing again. All right, let's put this to work for another example. So now we have a jogger. What is the key difference between this graph and the tortoise versus hare graph? So you'll notice they both have time on the x-axis. So here we had number of hours, number of minutes, but look at the y-axis, distance traveled versus speed. So the y-axis has distance traveled on the first graph, and speed on the second graph. All right, what is happening in each section of the function shown? Okay, so from 0 to 2 minutes. So here's 0 minutes, here's 2. So from 0 to 2 minutes, the function is increasing. From 2 to 3, decreasing. From 3 to 5, this is where we would say constant. Staying the same. From 5 to 7, increasing again. From 7 to 9, we have constant again. And then decreasing. Right, and we talked about in class some reasons for why you might have these constants. So think the jogger is picking up, speeding up, right? And then during those first 2 minutes, he's getting faster and faster. Then he slows down and comes to a complete stop for 2 minutes, maybe to take a water break or to stretch. Then picks up again, and goes 10 miles per hour. Then stays at 10 miles per hour for 2 minutes, and then slows down and comes to a stop of 0 miles per hour again. All right. So let's analyze these graphs. Okay, so we're going to describe each line segment as linear versus nonlinear on the first line, and then as increasing, decreasing, or constant on the second line. All right, so A to B. A to B is linear. It is just a straight line that I could go over that with my ruler. And it is increasing. From B to C, we are decreasing, and that is also linear. From C to D, also linear and increasing. And then from D to E, also linear and increasing. All right, now we have when x is -4 to x is -2. So x is -4 will be right here. When x is -2 would be up here. So from the value x equals -4 to x equals -2, it is a straight line, linear, and it is increasing as you go from left to right. Then from -2, x is -2 to x is 0. Here's where x is 0. That is decreasing. And it is curved, so it is nonlinear. All right, and then the next stretch from x is 0 to x is 2, that is also curved, so nonlinear. And that is going upward, so we're increasing again. And then from x is 2 to x is 5, even though that looks curved, there you go. It is straight line, so that is linear, and we are decreasing again. All right, 2 more for C. From x equals -6 to x equals -3, that is a straight line. And it is going upward, so it is increasing. From x equals -3 to x equals 0, just while I have the highlighter, okay, so for this green one, x is -3 to x is 0. It is constant because it is a flat line, and it's linear. It's a straight line, though. Then we have linear again as we go from x is 0 to x is 3. And here we're decreasing. We're going downward as you go from left to right. From x is 3 to x is 6, we have a curve, so that would be nonlinear. And it's headed upward as you go from left to right, so increasing. Okay, and let's look at D. All right, so I'm just going to highlight our first stretch, our second stretch, our last stretch, and our second. Okay. From x is -6 to x is -3, we have a straight line, and it is increasing. Here we also have a straight line, so linear, and it is constant because it is flat, slope of 0. Here we have an increasing linear again. Straight line, you could go over that piece, that pink piece with your ruler, and it's increasing. And then this green one, we're still going upward, increasing, but this time it is curved, so that means it is nonlinear. You cannot go over this with a ruler in one stroke. All right, so just going to show you again. Make sure you understand this vocabulary. Linear versus nonlinear, straight line versus a not straight line or a curve, constant rate of change for linear. The slope will vary for nonlinear. All right, thanks for watching.